Vegana presents. Machines. Programmed by John Ferguson Aditi. Learning objectives. After learning this unit, you should be able to 1. Explain the term machine. 2. Give examples of simple machines. 3. Describe the types of levers and the principles involved in their use. 4. Explain the terms work, energy and power. 5. Explain input work, output work, and efficiency as they apply to machines. 6. Explain the terms compound and complex machines. 7. Outline how to care for machines. Machines.
What is a machine?
A machine is a device that converts physical energy into a mechanical energy. It is a device that makes work more easier or faster. It is a device which enables a small force, or effort, to overcome a large force, or load. The simple machines that make up everyday life are 1. Wheel and axle. 2. Gears. 3. Screw. 4. Inclined planes. 5. Pulleys. 6. Levers. 1. Wheel and axle. A wheel and axle is a simple machine consisting of two wheels of different sizes, made up of a pulley and an axle. It is able to rotate through a complete circle 360 degrees. The circle turned by the wheel is much larger than the circle turned by the axle. The increased distance over which the force is applied as the wheel turns results in a more powerful force on the axle, which moves a shorter distance. For a wheel and axle system. 1. Both the wheel and the axle are grooved to take a rope. 2. Rope is wound round the wheel to leave a free end, where effort is applied. 3. Rope is wound round the axle in opposite direction to the wheel and the load attached to its free end. 4. When the wheel undergoes a complete rotation, the axle also undergoes one rotation. 5. For one rotation, effort moves through a distance equal to circumference of the wheel, while load also moves through a distance equal to circumference of axle. For example, the steering wheel, screwdriver, faucet handle and wrench. Two. Gear. Gears have teeth around the outer rim. When the teeth of two gears fit together and one gear turns, it will cause the other gear to turn, but in the opposite direction. When the gears are the same size, and they have the same number of teeth, they both turn at the same speed. However, if one gear is larger than the other, the smaller gear will turn faster. We use gears to regulate speed and direction of motion in complex machines, and to increase or decrease the force applied. Machines that use gears include clocks, bicycles, cars, egg beaters, and other small household appliances. Three. Screw. A screw is an inclined plane wound about a nail. The ridges are called the thread of a screw. These threads cut a groove in the wood, as you turn the screw, making it hold very tightly. To remove a screw, you have to turn in the opposite direction with a screwdriver. It is very difficult to remove a screw by pulling it straight out. The distance between the threads depends on the slope of the inclined plane. The steeper the slope, the wider the thread. Screws with less distance between the threads are easier to turn. Four. Inclined plane. An inclined plane is a simple machine that consists of a plane or sloping plank, inclined at an angle to the ground. An inclined plane is a flat surface that is at an angle to the load. This type of simple machine has no parts that move. An example of an inclined plane is a ramp for wheelchairs. The inclined plane of the ramp makes it easier for the person in the wheelchair to move up into a building. The ladder and staircase are also examples of inclined plane. The greater the angle or slope, the smaller the effort required. The inclined plane is used as a machine to roll heavy loads, such as barrels of cooking oil and bales of cloth into trucks with less effort. Therefore, an inclined plane is classified as a machine because 1. It enables work to be done faster and easier. 2. A heavier load could be overcome by a smaller effort, by pushing the load up the inclined plane, than by lifting the load directly upward. Five. Pulleys. Pulleys are simple machines, involving one or more grooved wheels and a rope. They make work easier to do. In a pulley, a load is attached to one end of the rope, while the effort is applied at the other end. Here, the rope passes through the groove, and when pulled, helps to raise the object up. Pulleys are usually used to lift things. For examples, a pulley can be used to hoist a flag, lift water from a well, or lift mortar or cement blocks to the top of a building under construction. Cranes used at the harbors to load and unload ships have pulley systems. Types of pulleys.
How many types of pulleys do we have?
There are two types of pulleys. They are 1. Fixed pulleys. 2. Movables pulleys. Note: in some pulleys, the number of pulleys in the system is equal to the velocity ratio. If the pulley system is perfectly efficient, the mechanical advantage, MA, and the velocity ratio, VR, are both equal to the number of pulleys. Hence for a 3-pulley system, VR equals 3. MA equals 3. Below are examples of pulley systems. Lever.
What is a lever?
A lever is a rigid body, which rotates on its axis called fulcrum. It is a simple machine that consists of a rigid bar, which turns freely about a fixed point called the pivot, or fulcrum. A lever can also be defined as a device, which is used to overcome a force called the load, by applying another force called the effort. A lever can also be defined as a device, which is used to overcome a force called the load, by applying another force called the effort.
Into how many parts is the lever divided?
A lever has 3 main parts. 1. Effort. 2. Pivot, or fulcrum. 3. Load. The effort is the force applied at one end of a lever to overcome a load. The load is the force to be overcome by the effort at one end of the lever. The pivot is the turning or rotational point of a lever. In levers, the positions of the pivot, effort and load determine the class of the lever. Classification of levers.
How many classes of levers do we have?
There are 3 different classes of levers. They are: 1. First class lever. 2. Second class lever. 3. Third class lever. First class lever. A first class lever is a lever that has the pivot between the load and the effort. That is, LPE, or EPL. Example of first class levers. 1. Seesaw. Seesaw. 2. Crowbar. Pair of scissors, or shears. 4. Claw hammer. Claw hammer. 5. Pincers. Pincers. 6. Pliers. Pliers. 7. Beam balance. Beam balance. 8. A rod being used to lift a stone from the ground. A rod used to lift a stone. 9. Spanner. Spanner. 10. Shovel. 10. Shovel. 2nd-class lever. A 2nd-class lever has a load between the pivot and the effort. That is, PLE or ELP. Example of 1st-class levers. 1. Wheelbarrow. 2. Bottle opener. 3. Nutcrackers. 4. Paper cutter. 3rd-class lever. This is a lever that has the effort between the load and the pivot. That is, LEP or PEL. Examples of 3rd-class levers. 1. Pair of laboratory tongs. 2. Sugar tongs. 3. Fishing rod. 4. Nail clippers. 5. Cutlass. 6. Hoe. 7. Tweezers. 8. Forceps. 9. Forearm of a human body. Note: 1st-class lever, pivot, is in the middle. 2nd-class lever, load, is in the middle. 3rd-class lever, effort, is in the middle. Levers in the human body. Some parts of the human body act as levers. Here muscles exert a force, while the joint acts as pivot. Examples of all three classes of levers are shown in the figures below. First class lever, action occurs at the neck. Second class lever, action occurs at the ankle. Third class lever, action occurs at the upper and lower arms. This picture illustrates the levers in the human body. Work, energy and power.